During the day, we can see the sun, and at night, we can't. But in the end, that difference doesn't really matter because both during the day and at night, from here on the Earth's surface, we can see how the sky is equally bright and clear. And I know that idea sounds strange, but pay attention. Imagine you're in the middle of a forest, but this is not an ordinary forest. It has an infinite number of trees. And what's even more impressive, now imagine that all of these trees were painted white. In this peculiar situation you find yourself in, it doesn't matter which direction you look, you will always see the color white on the horizon. In your field of view, when the silhouette of the nearest trees ends, their whiteness blends with the whiteness of the trees farther away. In the end, everything around you is white. Now, let's suppose that instead of finding yourself in a forest surrounded by infinite white painted trees, you're in a universe surrounded by infinite shining stars. The principle would be the same. When the luminous silhouette of one star ends, its glow would blend with the glow of more distant stars, so the sky should be lit in all directions, both day and night. I don't know if you've ever tried this experiment, but looking up at the sky at night gives you one undeniable truth. The sky is dark. But why is it dark? Shouldn't it be as bright as day? Well, this is Olbers Paradox. The simplest solution to this paradox is to imagine that something is blocking the light on its way from distant stars to Earth, like a massive amount of cosmic dust. As far as we know, the universe is made of vacuum, vacuum, and more vacuum. There simply isn't that much cosmic dust, and even if it did exist, the light radiation from infinite stars would heat those dust grains so much that they would shine just as brightly as stars. And in fact, that would also be the fate of any matter in the cosmos. Under the radiation of infinite stars, the Earth as we know it would be entirely vaporized within hours. But even so, that doesn't happen. Why? Could it be that the light from very distant stars loses intensity, and when we look from Earth, their glow is just too faint? Well, if we imagine ourselves in a completely dark room with only the light of a candle, we can notice that the farther away it is, the dimmer it appears to our eyes. In fact, there's even a mathematical description of this physical phenomenon, where as distance increases linearly, light intensity decreases by the square. That means the same candle at twice the distance appears 4 times dimmer, which is a big difference. That's not wrong if we're talking about a single light source. However, in the universe, there are infinite sources, infinite stars scattered more or less evenly. To visualize the effects of that, think of us encapsulating the Earth in an imaginary shell. This is a very large shell with a diameter of several light years, and right at the center is our planet. It's so immense that eventually we'd find some stars along its edge, so we could say that part of its surface would emit light, right? Now imagine we add a second imaginary shell, identical to the first, but its edge is even farther away, encompassing not only the Earth, but also the first shell. If the edge of shell number 2 is twice as far from Earth as shell number 1, its surface area will be 4 times larger. Distance increases linearly, while surface area increases squared, just like the diminishing brightness. In other words, shell number 2 is 4 times more likely to have stars on its edge. However, that's compensated by the fact that each of those stars appears 4 times dimmer to us. Looking at all the stars together, both imaginary shells would emit the same total light intensity. Distant stars from our planet are, in fact, individually dimmer, but the number of them increases in the same proportion. Night should still be as bright as day because of these imaginary shells. So the only thing left that could explain why we basically observe darkness during the night is the expansion of the universe. The universe is growing, expanding faster than the speed of light. So if a star is far enough away, the light from its glow will never reach our planet. It's in a losing race against the expansion of space. Also, if the universe is expanding, that means if we went back in time, its size would shrink more and more until we reach the point where everything that exists was concentrated in an infinitely small point. Once we reach that moment, we'd be witnessing the Big Bang, the birth of the cosmos. If the universe has a date of birth, that means it's not eternal. It has a defined age, and as far as we know today, that age is about 13.7 billion years. And that number tells us that the light from distant stars has only had a few billion years to reach us. All the stars that are too far away simply haven't had enough time for their light to arrive here. However, someone could still make one last counterargument and say that if the universe has a beginning, then when it was still young and small, shortly after the first light came into existence, the light waves were able to spread everywhere. In all directions, there was a glow as intense as the surface of a star. But today, we can't see that glow. The night should still be as bright as day. Well, yeah. And upon hearing that, I would say the night shouldn't just be as bright as day. The thing is, it is that bright. As the universe kept expanding faster and faster, that intense light that should be everywhere also got stretched out. And the wavelength of that light became longer and longer. It actually got so stretched out that those high-energy waves from the young universe ended up becoming more attenuated. What once had a wavelength visible to the human eye ended up becoming microwaves. So the cosmos is shining in all directions. It's just that we humans can't see it with our eyes. But with the right equipment, humanity can point telescopes at the sky and admire the microwaves left over from the Big Bang, from the beginning of time. They illuminate our planet every moment. Through technology, we're able to reveal parts of the cosmos that were previously unknown, even the most unexpected ones. Today, we can confidently say, the night is as bright as the day.